Okay.
26 to 35, Naomi will stamp those, you can just leave them out. And then 8.2 is the assignment where we took some notes last time.
So the water unit, you know what it is that's in tap water?
Yep. What makes tap water taste funky? Almost all that contains chlorine, which is added to keep the water from harboring biotic pollution. So it's a way to sterilize the water. By the way, if you want your tap water to taste delicious and awesome, put it in anything that doesn't have a lid for like 24 hours.
What happens to it?
Chlorine off gases. So like, you know, your fridge probably smells rank. Like most of us don't realize because we don't spend a lot of time in there. But like, once the fridge door is closed, the smells in there get really foul. So if you leave something uncovered in the fridge, your water will pick up the funk taste of your own fridge. But if you leave it like with a rag on top or cheesecloth so that the chlorine can vent out, you're not going to pick up a lot of particulate. Usually you get water that tastes like mountain spring glorious. Something else is that our taste buds respond to temperature. They're more or less active depending on temperature. So you make water taste a lot better by making it cold. Yeah.
Yeah, how does it show like big difference in water? Tap water.
Yeah, like all I drink is tap water.
Does it have to be filtered first?
No, I mean
Tap water is like auto regulated.
yeah, what he said.
That actually like has to be cleaner than bottled water. Like it doesn't have to bottled water.
Right. Most bottled water is tap water that has salt and sugar added. And in the process, they remove the chlorine so that you won't notice the chlorine taste, which none of us like. But the flip side is by removing the chlorine, it can harbor a pollutant. So if one of the lids doesn't close right, or some fleck of God knows what makes it into there before they put the lid on it, without chlorine being in the bottle, they're actually not a sterile environment.
Okay, so your tap water is more sterile than your bottled water?
Oh yeah. And everybody should know that. Did you all know that tap water is regulated much more carefully than bottled water?
Yeah.
Yeah, exactly.
What if you have like a soft water system? What does that do?
Well, your biggest problem with water pollution is your own system. So all the crap you've got in your house, as soon as that gets a leak, as you miss a service day, as you get a little backflow from water from something else that goes back into your system and it's colonized by who knows what, that's a really good way to make the water safe.
Okay. But if you have soft water, it's fine with me.
Probably. Okay. Last time we were all here, did we talk about that one?
Yeah.
Talk about that one?
Not really.
We stopped here.
Okay. That's what I was hoping. So I believe we are on number 13. And this diagram for number 13 shows you 3 interactions between ground and surface water. I have to warn you that usually we forget that surface water will go into the ground, and a lot of our surface water came from groundwater. I may have told you about a friend of mine who has a farm in Northern California. Did I mention this? Where in a drought year, he soaked up a lot of groundwater, so both of his neighbors, their creeks went dry. They had year-round creeks, and he took away all their water. Because please look up, when you take down this water, that would take down this water too. His neighbors had what was called effluent streams. It was exposed groundwater. When he sucked down the groundwater for his farm, his two neighbors' ponds went dry. Years later, they realized that one of their other neighbors, further up on one of those streams, had like a big lot full of crappy old cars, and he used to throw all of his car batteries down this slope where apparently they had been falling apart and polluting the stream. One of those streams that's connected to the groundwater. So the groundwater he was sucking up for his organic farm was found to have a variety of contaminants that could be traced to car batteries on its neighbor's surface water pollution. The reason I mention this is what my farmer buddy did to his groundwater affected the supply of surface water for his neighbors, and what his neighbors did to the quality of their surface water affected his quality of groundwater. Groundwater and surface water play together. And there are 6 ways that they do this. Like I mentioned, number 1, water pumped from wells lowers the level of groundwater, which reduces stream flow. There is that interplay of agricultural water extraction or water pollution with ground and surface. Number 2 on this diagram is one of my favorites. We're going to talk about this. Wherever you have a city, you have less recharge. Because imagine, this roof over our heads is like a giant umbrella that takes rainfall, and instead of recharging into the ground, that rainfall comes off the umbrella out to this concrete, which goes to that asphalt, which goes into that gutter, which gets rushed out to the ocean. Don't forget that cities have this. So urbanization reduces recharge. You know what I mean about the umbrella over the groundwater? Impermeable surfaces, so you shed your rainwater. And this adds up to some pretty significant numbers. Apparently, Los Angeles could provide all of the residential water it needs if they just had a way to store their rainwater. Instead, Los Angeles, because it's in a desert on the coast, they have to shed all their rainwater out to the ocean quickly, and then for all their residential water, they have to pull it all away from Colorado and the Sierras. Kind of a wacky concept.
It's not enough water to affect the ocean.
I beg your pardon?
It's not enough water to affect the ocean. It's too minimal, right? It's like to change. You've got a bunch of coastal cities washing all that in the ocean. It doesn't really matter because it's too small.
Well, the quality of the water is a problem because of the pollutants that the water carries. You mean in terms of the salt balance of the ocean?
Yeah, it's just too small.
It wouldn't matter if we melted all the ice caps, all the snow, stopped all the rain, and put all the surface water into the ocean. Because of all the water on Earth, 97 point some % is already salty. Even if we could dump the other 2.5% into the ocean, to the net volume of, to the net salinity of that giant volume, it would make a very subtle change at the most extreme scenario.
From like water from residential areas, like
Oh yeah, we'll talk about that. That's a big part of this unit. We'll get to that. Remember number 3 and 4, both sewage treatment and agriculture, they both add nutrients to groundwater. Number 5 is a reservoir, and reservoirs create recharge mounds. That's a big way. Wherever we stash water on the surface, that also means we're stashing water underground. Yeah, so reservoirs encourage recharge. And number 6 is kind of a relatively small issue. Those are supposed to be houses, and houses have septic tanks sometimes. And septic tanks, like wastewater treatment, also add nutrients to groundwater, or if you're at Rincon, they add nutrients into the ocean directly. But I want to talk a little bit more about what happens with cities. The first thing I want to tell you we could have developed a different status quo for civilizations. But in most of our cities, water is a problem. When the baby Jesus cries water onto us, we need to get rid of those tears. So this afternoon when it rains, you'll notice the city of Santa Barbara doing something extremely unnatural. In nature, when it rains, that water hits the earth, most of it soaks into the ground, and once the ground is saturated, some of that water will trickle along the surface, tumble into streams, gather into rivers, and rush out to the sea. In a natural landscape, as an average across the earth, less than 10% of rainwater makes it to the ocean. More than 90% of rainwater soaks into the ground and is added to the biomass of plants and animals, I guess. But in cities, think about it. If we kept all that water on the surface, our shoes would get wet. Our houses might flood. Our construction might suffer. Our roads would be less safe. Our school buses might hydroplane and plow into our hospitals. I'm glad you're all entertained by that thought. But I think you understand the point that in our urban landscape, water on the surface is a problem. So something that we rarely think of, like when you look at the Riviera, when you look at any place that has houses, but for example, the Riviera, it's this perfect layering of impermeable surface. And think about it. All those roof tiles are stacked so that the water will pour off one tile and then drip down to the next one and drip. You know what I mean, right? So they're like stair steps. All that rain comes off the roof, falls to the sidewalk, sheds away from the building because the sidewalk's at an angle to go to that asphalt. That will rush down to those gutters. I see the gutters, maybe you can't right now. There's a gutter along this chain link fence. That gutter will go out where those dumpsters are, spill underneath some dirt, and become a street gutter on the Canyon Perdido entrance to our school. That water will go gutter, 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 all the way down, out to the ocean. cities are just impermeable surfaces shedding their water to another impermeable surface so we can get rid of our water as quickly as possible. It really makes sense.
Like where did cities that are in like
Rivers,